In this video, we will look at 2015 H2 Physics, Paper 2, Question 2. As usual, before we start a question, we should quickly skim through the parts to have a quick overview. So you can see in Question 2, for the first part, we are given a I versus V graph for a resistor X and asked to show that I is proportional to V. In Part B, you are told that resistor X is now placed in a circuit, and in the parts that follow, asked to make calculations on resistance, currents, and potential difference. Let us now look at the question in detail. In Part A, you are given a graph of I versus V for a resistor X and to show that I is proportional to V. If we look at figure 2.1, we can see that we have a linear graph of I versus V. Hence, I can be written as I equals to kV plus C, and our task is to show that C is equals to 0. We don't have K, and we need to show that C is equals to 0. Hence, we have two unknowns, and therefore we'll require two equations to solve. To get that, I just have to pick 2 points off the graph and substitute it into the equation and solve for C. That will be the strategy. So I'm going to use 12, 2.5, and 6, 1.25. Substituting these into equation 1, we will have 2.5 equals to 12k plus C and 1.25 equals to 6k plus C. Solving the two equations, I will have C equals to 0. Hence, K is equals to IV and I is proportional to V. Shown. Before we move on to Part B, you may want to quickly think about the implication of this calculation, as we know that we will be placing this resistor X into a circuit. Since I is equals to kV, rearranging the equation, we will have V over I equals to 1 over K. Since K is a constant, V over I is also a constant. And what is V over I? V over I is the resistance R, and that tells us that resistor X is actually a constant. Let us keep this in mind when we solve the questions in B. We will now move on to Part B. In Part B, we have a power supply of 12 volts with no internal resistance. This is connected to a resistance wire of AB and a resistor of 5 ohms, which I'm going to call L1. We are further told that wire AB has a length of 1 meter and its resistance is 4 ohms. Resistor X is placed in series with resistor Y in the branch below. For circuit questions, you may want to put the information in the diagram as you read, as that will help to look at a glance all the information given. Let us now move to B Part 1. In B Part 1, we are asked to calculate the resistance of resistor X. Recall that earlier, we have said that the resistance of resistor X is a constant, and we know that R is equals to V over I. Hence, we can use any pair of values of IV from figure 2.1 to find the answer. In this case, I'm going to use 12 and 2.5. Substituting it into the equation, I will have 4.8 ohms as the answer. Next, we will look at B Part 2. For B Part 2 Part 1, we are asked to calculate the current in the wire AB, which I'm going to call IAB. From figure 2.2, we can see that the current through AB is equals to the current through R1, which is also equals to the current through this whole branch. I'm going to call this point E, and hence we can write IAB equals to I1 equals to IAE. Now, IAE equals to the potential difference across AE divided by the resistance in the branch AE. We note that the PD across AE is equals to the PD across this top branch, which is the EMF of the cell. Hence, we can write VAE to be EMF of the cell and RAE as the resistance of wire AB plus the resistance of R1. We know that the EMF of the cell is 12 volts, RAB is 4 ohms, and R1 is 5 ohms. Putting it into the calculator and computing, you should be able to get the answer as 1.33 amps. Now for B Part 2, Part 2. In this part, you are asked to calculate the current in resistor X. So the current we are interested in is in this branch here, which I'm going to call FG. We note that the potential difference across FG, again, is the same potential difference across the cell. And the current through X is the same current through Y. Hence, we can repeat what we have done above and write Ix equals to VFG over Rx plus Ry. We know that the potential difference across Fg is equals to the same potential difference across the cell, which is 12 volts. Rx is 4.8, which we have calculated earlier, and Ry is 2.7 ohms. Hence, again putting it into the calculator, we should have 1.60 amps as the answer. Moving on to the last part of the question. In this part, you're asked to calculate the potential difference between the points C and D, which is this point and this point. You're also given that point C is at a distance of 75 cm away from A. Now, if we have the potential at C and the potential at D, we can do a direct computation for the potential difference. However, we do not have both the potentials. So how do we do the question? Let us look at what we are given. In the question, we are already given the length of AC. From the length of AC, we should be able to find the resistance of AC. Since we already know the current through this wire, we should be able to also find the potential difference across AC. What about D? We first note that the potential at A is equal to the potential at F. We can also find the potential difference across FD, as that is the potential difference across X. We have the current through X and the resistance of X, and that will allow us to determine this potential. Let us put this in a diagram for easy comparison. If we have the potential difference across AC, and if we are able to find the potential difference across FD, we know that the potential at A is equal to the potential at F. Taking the difference between these two quantities will allow us to determine the potential difference across C and D. We can now go and work out the problem. So, we will first determine RAC. Since this is a uniform wire, we know that the resistance is proportional to the length of the wire. Hence, RAC over RAB equals to LAC over LAB. Rearranging and making RAC the subject of the equation and substituting the values in, you will get RAC to be 3 ohms. With that, we can determine the potential difference across AC. The potential difference across AC is the current through AC times the resistance of AC. From previous calculations, we have IAC to be 1.333 amps and RAC to be 3 ohms. Hence, we will have VAC to be 3.999 volts. For potential difference across FD, it is simply the current of X times the resistance of X. Substituting in the values earlier, we have 7.68 volts. With that, the potential difference across CD is the potential difference of FD minus the potential difference across AC, and that will give us 3.68 volts to be the answer. This brings us to the end of question 2.